Hello friends, I am Suk and today I am going to walk you through a very important spec in the GCSEs, irrespective of any boards, whether it's AQA, EdXL, Educas, OCR. But in this lesson, we will focus on AQA specification, right? So forces, this topic, force, contribute a major chunk of your GCSE AQA physics portion, right? So as you can see on your screen, these are the portions which we will going to understand in this topic. And in this video, we will focus on the first three, that is scalar and vector, contact and non-contact, and the gravity. And rest we will see on the next tutorial. Considering the length of the video, we have divided the whole portion of force into two different tutorials or lectures. Okay, now let's start the first topic, which is force. Okay, now in the first portion we are going to learn about a scalar quantity. Now first we have to understand what is a scalar quantity. As you can see, a physical quantity is something that can be measured. The scalar quantity only have a magnitude or size. What does that mean is any such unit or any such entity or say quantity which only have a magnitude. Okay, when we say magnitude, it means it has some constant values. Okay, now when we say constant, we mean it is having a defined value, a defined number. Okay, let's say for example the temperature of 10 degrees Celsius. That 10 is actually a magnitude, means it's have a defined number. Okay, a mass of 5 kilogram, an energy of 2000 joules, a distance of 19 meters. So any such entity or quantity which comprises of only magnitude, which means a defined value, a predefined value, and that is called a scalar quantity. Okay, now it can be anything which is defined by a constant, okay, or a magnitude, right? It can be mass, it can be speed, it can be distance, it can be temperature, it can be density, anything. Okay, now now coming to the next, the addition of scalar quantity. So scalar quantity can simply be added by adding those numbers. So let's say I say that a Jack is weight of 25 kilogram, mass of 25 kilogram, and Jones has a mass of 15 kilograms. What is their total mass? So you gonna just add them up. So as you can see in an example, calculate the total mass of 75 kg climber and 15 kg backpack. What you gonna do, you're gonna simply add those values to get 90 kilogram. So that's the that's the beauty of a scalar quantity. You can simply add to get a defined value. Okay, now coming to the next, which is a vector quantity. Now, what is a vector quantity? A vector quantity are those quantity which have the magnitude and it has an associated direction. Now let's try to understand. Suppose you want to go from your home to Barking tube station. Now suppose your home is at H and this is a Barking station. Now from home to Barking station, let's say you have a distance of 5 miles, right? Now when I say your distance from your home to Barking tube station is 5 miles, it means I am talking about a scalar quantity because it has a magnitude. Now when I say, now suppose your friend has reached to your home and you want to tell him how to reach to Barking station. Either he will open a Google map or iOS map, or you gonna guide him manually, hand signals. Okay, now you can't just say that my home to the Barking station is 5 miles, right? You need to tell him or her that you have to take the first left, then third exit from the roundabout, then the second exit from the roundabout, then take a right from the T junction, and etc. Now these, when in your direction, when in your speed you are adding this direction, then your quantity becomes a vector quantity. Okay, now since till this 5 miles it was pretty easy, it was pretty straightforward, means you are reading or understanding a scalar quantity. But as soon as your friend want a direction to reach to the Barking station, you need to explain him or her about the directions. First left, then you need to take the exit from the second roundabout, then right, and then you reach to the Barking station. Now this is a vector quantity. Okay, why it become a vector quantity? It's because you are adding a magnitude with directions. Okay, and this is called a displacement. Okay, which has a magnitude as well as direction. Okay, now till the distance is a scalar quantity, but the displacement is a vector quantity. Similarly, any physical quantity which carries a direction with the magnitude, that becomes a vector quantity. For example, force. Okay, now if I say apply force of 20 Newton, you need to mention where. Okay, you need to apply on a box, which will move the box toward left, toward right, or straight. You need to pull the door, you need to pull or push the door by applying 20 newtons. So when you apply that force, the door will either push forward or pull backward, etc. Velocity, displacement, we have seen velocity, speed. When we say speed, it's a scalar quantity, but as soon as you add a direction to the speed, you will become a vector quantity. For example, you need to move from your home to Barking station with a speed of 11 miles toward right, 10 miles toward left, because it was a congestion. Then you have to move to at 20 miles per hour because it was a 20-mile zone, and etc. Then acceleration is also a vector quantity. Momentum is also a vector quantity because it all have the directions. Okay. Now, this is the meaning of a vector quantity. Moving on, what are the different type of forces? So first type of force is a contact force. So what are contact force? As the name suggests, the force are that act between two objects which are physically touching each other are called contact forces. Means, suppose you want to push or pull a door, you can't just blink your eyes and it can happen, unless if you are a magician. All right, now you have to use your hand, place it on the door handles, and then apply force to push or pull the door. That is called a contact force. All right, so that is basically called the contact forces. Right, now the first type of contact force is the reaction force. What is a reaction force? An object at rest on the surface experience a reaction force. For example, a book on a table. Whenever you have placed a book on a table, that book will, as the book will exert a force downward, the table will also exert a force upward on that book, and that is called a reaction force. Every action has an equal and opposite reaction, Newton's third law. Okay, now tension. Second, the tension, an object that is being stretched experience a tension force. For example, a cable holding the ceiling lamp. For example, in your house, if you have a chandelier, it's being hanged by some kind of rope with the ceiling, and there is a force which is being exerted back through that rope. That is called a tension. Okay, and that tension force is exerted in this rope, okay, by this object. Okay, now see, this object is hanging downward. It will exert a force in the downward direction. At the same time, this object will exert a force in the upward direction with the material with which it's being hanged with the ceiling. Okay, and that's called a tension force. All right, anything which is being stretched, okay, that exert a tension. Moving on, friction. Very straightforward. Anything which the two objects, when sliding past each other, experience a friction. As you can see in the diagram, the box, if it is sliding down in the downward direction, there is a force of friction which will oppose this box moving downward, and that is called a frictional force. Okay, now next, air resistance. An object moving through the air experience an air resistance. Okay, now anything, let's say for example, the skydiver, when he jumps from an aircraft, right, experience a drag, experience a opposition, and that opposition is caused by air. Okay, we must have kind of seen that, okay, there is nothing pulling me back, then what is resisting us or resisting me? And that is called an air resistance. Okay, that also comes under a contact force, because that air is in contact but we can't see it. Right, so that is basically an air resistance. Now comes the non-contact force. Now, what is a non-contact force? Non-contact force are those forces which are not connected with physically or being touch each other, and that's basically is called as non-contact force. Right, now the first type of non-contact force is a magnetic force. Okay, now what is a magnetic force? The magnetic force is being experienced by any magnetic material in the magnetic field. Now we know what is a magnet. Magnet are those substance which has the property to attract and repel each other. Okay, so the magnet has the poles, as you can see. S denotes south and the and denotes north. Okay, so the magnet has the property that where the unlike pole attract each other. Unlike pole, when I say, means the north and the south, they are unlike, they are not, they are different. Okay, so these will attract each other. The unlike pole attract each other and the like pole repels each other. Like pole means north and north, south and south. If south comes near to the south, then they will repel each other. Now that is called as magnetic force. Okay, you don't have to bring the magnet in physical contact with each other. They will automatically exert the force, whether it's like or unlike, or whether it's contact, or whether it's attract or repulse. Okay, that is called a magnetic force. Now the next is an electrostatic force. Electrostatic force are exerted by the charge particle. Now I will quickly give you a brief what is a charge particle. In an atomic world, an atoms consist of proton, electrons and neutron. Protons being the positive charge, neutron being the neutral charge, and the electron being the negative charge. Now protons and electrons, if they come closer to each other, they will attract, because protons is a positive and electron is a negative. Now if two electrons come near to each other, they will repel. Similarly, if two protons come near to each other, they will again repel. Okay, now what does that suggest? That its kind of property behaves the same as magnetic, only difference is the difference in the type of element. Okay, here we are talking about the charge particle. Okay, charge particle in the atomic world, right? Okay, now moving on. Gravitational field. What is a gravitational field? So gravitational field is basically all the object with mass produce a gravitational field. Anything in the world which has mass, that will try to make a force of attraction toward that object. The greater the mass, the greater the gravitational field. Okay, so any object which has the mass will try to attract anything coming in the vicinity of that object. All right, now gravitational field strength, the weight, and so in this we will try to understand a weight. So the weight is a force acting on an object due to gravity. Okay, and its unit is newtons. Now we will try to understand what is the difference between a weight and a mass. Okay, now when we say I weigh 70. If I say you, I weigh 70 kilogram, is it true statement? It's not true, because weigh is the unit of weight is newtons. So I will always say I am 70 Newton. Now, what is the difference between weight and a mass? Okay. Now, always remember, weight is equals to mass times gravitational weight is equals to mass weight is equals to mass times gravitational field strength. Okay, now when we are on in the earth, okay, we cannot, it's when we weigh ourselves on a weighing scale, it will always give you your weight. It cannot give you your mass, because by default when we are on the planet earth, this gravitational field strength will automatically apply on your mass to give you a weight. Okay, now what is mass? Mass is the amount of quantity which is present in any object or even us. Okay, that is a mass. Okay, now always remember, when we are, as I mentioned you, when we are on the planet earth, or say any other surface, you are always being exerted with a gravitational field strength which is by its own for the object where we are located. So for say for example for earth, this gravitational field strength is 9.8, which is a constant value. Okay, now when we are weighing ourselves on a weighing scale, let's say it gives you 70, it's basically your weight, which is 70 Newton. Now if you want to find out your mass, that will be 70 divided by 9.8. That will give you your actual mass, which is in kilogram, and that is amount of material or quantity present inside your body. Okay, and that is called as your mass. Right? Okay. Now moving on to the next. Now this is what we have just done, the concept of weight. So weight is equals to mass times gravitational field strength, which is G. So weight is equals to mass times gravitational field strength. Right. Okay, and the units are already given. Weight is always measured in Newton, mass is always measured in grams, and G, which is gravitational field strength, is newtons per kilogram, because weight is equals to mass and grams. So if you make gravitational field strength, so this will be weight over mass. So this will be what? Weight is Newton and kilogram. So G's unit is 9.8 Newton per kilogram. Okay, this is an important equation. Now moving on, how to calculate a work done. So before that, what is a work done? Work done is when the energy is transferred from one source to one store. Energy is transferred from one store to another. See, work done means, let's suppose you are doing some work in pulling or pushing the door. It means what? You are transferring an energy from your body towards that door, and that energy is allowing the door to move far or move or come toward you. Okay, now that is called the work done. Okay, and energy is basically transferred. As we know, in the concept of energy can never be created nor even destroyed. It can change forms. So when you are pulling or pushing the door, the chemical energy inside your body, which has came in your body from the food, that has been transferred to the energy in the door, which is allowing the door to push or pull. Okay, now work done is equals to force times distance, means the amount of force which is applied on the door that has moved the door through some distance. So always remember, if you have done some work, then it is governed by some distance and the applied force. Okay, now work done is measured in joules, force is in Newton, and distance is always in meter. You always have to remember these units. These units are very important. In the question, they may give you the force in kilonewton or anything. You have to make sure that you convert it into Newton to get the right value of work done, which is joules. Similarly, in the question, they can give you in miles, in kilometer, or in meter. You have to make sure that you convert this distance to meter, and that will give you joules, and 1 joule is equals to 1 Newton meter. Means 1 joule of energy have applied on an object of force by force 1 Newton and has moved by a distance of a meter, and that is called a work done. Now the next is resolving forces. Now what is resolving forces? See, we have seen how we have applied a force. Okay, now the force can be applied in different angles at a different points. There is no restriction of force being applied in an object. Okay, now as you can see, the two forces added together to find a resultant force. Now that is basically what it is called as resultant force. Now as you can see, a single force can be resolved into component force at a right angle with each other. Okay, in the diagram shows that a toy, when the child pulls on a handle, some of 5 newtons force pull the trailer upward away from the ground, and some of the force pull to its right. Okay, now what we are seeing that whenever you are applying a force in a toy of 5 Newton, and that is 37 degree with the horizontal forces, what is the resultant force? Okay, we will see that. Okay, now we can see that you need to make a component force, that is vertical force and a horizontal force. And this is horizontal force, and you are applying this force of 5 Newton with an angle of 37 degrees. Okay, now you have to always remember, to resolve a force you have to break down any force into a vertical and a horizontal components. Okay, right, now we will see why. Now we will see a free body diagram. See, as we have seen in the previous section, how we divide the force into 2 components. Now that application will be used to draw a free body diagram. Now what is a free body diagram? The free body diagram model the force acting on an object. Okay, now suppose a book is lying on a table. Okay, you don't have to draw the book, you don't have to draw that table, you don't have to draw a human who have placed that book on a table. But instead of that, what you will do is you will simply draw an object with a square or with a circle, and just with an arrow show the direction of the application of the forces. Okay, what are the places where the forces are being applied? Okay, now if you see an object, this is how, if you see, suppose a box is or a book is lying on a table, you will show with this diagram. So this is your book. It is exerting a force downward, which is in the form of weight, means the mass of the books times gravitational constant. If it is in earth, then it is 9.8 kilograms per newton, and mass can be, let's say, 1 kilogram. Okay, and there will be a reaction force which is acting on the upward direction, as we have seen. Okay, now this is how you will represent a free body diagram. Okay, by the arrows and by the dot. Now let's see some example of a free body diagram. Okay, now as you can see, the box is lying on a table, so there will be a force which is acting upward. So since these are balancing with each other, the weight of 0.2 newtons acting downward and the reaction force of 0.2 newton acting upward, and that's the reason, since they both are equal to each other, that's the reason why book is currently at stationary, at stall position. Okay, now suppose the book breaks this table and fall down. What does that mean? That means the amount of weight acting downward, okay, is greater than the reaction force. That's the reason why this has broken the table and crashed into the ground. Okay, now in the next diagram, as you can see, if the object is speeding downhill, then there, as we have seen, there will be a force which is acting opposite direction, which is a frictional force. There will be a weight which is acting downward, as you can see, and there will be a reaction force which is acting upward. Okay, now frictional force, why? Because as we have seen, two contact body, when they move, there is a force which opposes the direction of the movement, and that is called the frictional force. Okay, now this is how we will do the free body diagram. Right, now the next we will see about the free body diagram of a yacht or a boat or a ship or any object which is there on the water. Okay, now as we can see, as the boat is moving in the forward direction, there is a thrust of 800 newton. What is thrust? Thrust is a mechanical force which is applied because of some mechanical movement. It can be the gas, it can be the steam, it can be anything. So for this boat, the mechanical steam engine or diesel engine is allowing the boat to apply a force to and moving the boat with a force of 800 newton in the forward direction. There is an air resistance which is being applied with 200 newtons. There is an upthrust which is being applied. Now what is an upthrust? Upthrust is a type of force which is applied on any object which is on a water. Okay, remember, whenever any object is floating on a water, there is an upthrust which is applied toward in the upward direction over that object. That is called an upthrust, and that is allowing the object to float. Okay, now always remember, if the object floats, it means its upthrust will always have to equal to the weight. Now in any condition, if your upthrust is lower than the weight, then the object will sink. Okay, that makes the object float. If, let's say, the weight would have been 6,000 newtons but the upthrust is 5,000 newtons, then the object would have been sink. It would have been sink at beneath the water. Now the upthrust is the force which makes the object float on the water. Okay, now moving on. Okay, now we will see the vector diagram means how you represent a force. Okay, now we have seen in the previous slide that if the child is applying a force on the toy with the 5 Newton, how to draw a vector diagram. Now vector diagram, as the vector suggests, it gives the direction, means it has to, when you draw a vector diagram, you should have a direction. And second thing, as we have discussed, if you want to draw the component of applied force, you have to draw its vertical and the horizontal component. Now what is a vertical and horizontal component? The vertical and horizontal components are the distribution of the forces which is applied in any direction. Okay, now as you have seen, that toy was like that. Child is pulling that toy in this direction of 5 Newton and with an angle of 37 degrees with the horizontal component. So horizontal component is already drawn. So when you want to draw the vector diagram, you need to draw a vertical and a horizontal component. So what you are gonna do is, you gonna draw a horizontal component like this in toward this direction. This will be the direction, and a vertical component toward the end of this, which will be touching toward the end of this force in the upward direction. And this is the vertical component and this is the horizontal component. Okay, now you can ask that, okay, why the horizontal component is not like this in this direction and like this direction? It can be in this way as well. The answer is yes, you can. It's your wish. Okay, the idea is that if you want to, this is the direction of your force. Let's say this is A and B. This is the direction of the force. If you want to move from A to B, let's say this is D and E, you can take the path from A to E and E to B, or you can take the path from A to D and D to B. Okay, you can take any direction irrespective of which path you are taking. The idea or the main objective is to reach to B. You can go via any path. Okay, and this is called the vector diagram. Okay, now if you want to reach to this point to this point, you can reach in this way, you can reach directly in this way. Okay, and that is called a vector diagram. So what we see a line representing of 5 Newton at 37 degree, a horizontal line ending directly below the end of the first line, the vertical line between the end of the two line, and the arrowhead toward the show the direction of the forces. Okay, now this will give or you can say this gives you the vector diagram. Okay, right, good. Now let's move on to see some question. So pause this video and try to see what is being given and see what you understand here. So in the question it is mentioned that draw a free body diagram of a toy sailboat with a weight of 30 Newton floating in water, and that is being pulled to the right by the applied force of 35 Newton. Okay, now there is a toy boat which is floating in the water. It means what? If it is floating, means your upthrust will always be equals to the weight. That is the first thing which we have to remember. Okay, now there is a force of 35 Newton being applied to pull the boat. Okay, and right. Okay, now if you draw the free body diagram, it's pretty much kind of straightforward. What you have to do is that, let's say this was your boat. Okay, there is a force which is acting upward, there is a force which is acting always. And also students, remember, when you are drawing this arrow, what you can do is that if the forces you measure the length of the arrow with a ruler depending on the force. Let's say for example it's a 30 Newton, so you can mark it as something like this. Let's say 10 Newton equals 1 centimeter in scale. Okay, so in this way, if you draw your free body diagram, this will be 3 centimeter, this will be 3 centimeter. Now there is a force which is acting in this way, so this will be this is 3, so this will be 3.5 centimeter. Okay. Right. Now there will be a opposite force which will be acting, and that force will be air resistance. Okay, now you got it, right? So that will be your free body diagram. Now since we don't know how much air resistance was applied, so we will just draw the free body diagram, but we have to show the air resistance, but we don't know. But always remember, your air resistance will be less than 3.5 centimeter or 35 newtons, because the boat is moving in the forward direction. It means your applied force was definitely greater than air resistance. Okay, so but we don't know, but we have to make sure the length of this should be less than, means your air resistance should definitely be less than 3.5 centimeter. Right, so this is how you will draw a free body diagram for a boat which is sailing in the river or in a pond or in a tank. Now we will see the free body diagram of an airplane. Now if you see, when the airplane is moving ahead, there will be a thrust. Now this thrust is because of the exhaust or the engine which is allowing the this airplane to move ahead. Now see, there will be no upthrust. Why there will be no upthrust? Because this is not moving into the water. So there will be a lift which is allowing the airplane to fly in the air. Okay, now that lift will be because of the technical stuff which are there in the airplane, allowing the airplane to rise up. Definitely there will be a weight acting downward, and definitely there will be a drag or an air resistance which is acting opposite to the thrust. So what is the new we have learned here for the case of airplane is the lift. Okay, you also must have seen the air take off on the air. So it is because of the mechanical part which is allowing the airplane to move in the upward direction. Okay. Now this was all about the forces. Okay. Now we have seen all these three topics as we have discussed at the beginning of the lesson. We have studied about scalar and vector quantity, we have discussed about contact and non-contact forces, and we have discussed about the gravity. We have also seen how to draw a free body diagram. We have also seen how to do some questions based on the work done, based on the weight, and etc. Okay, now so if you have any question with regards to anything we have discussed on the first three topic and the force, do reach me out in the below mentioned email or at the phone number. Okay, and I will be happy to to assist you. Right? So let's wrap up the lesson for today, and we will see you on the part 2 of the tutorial to be start with force and elasticity, describing motion, Newton's law, and momentum. Right? Stay tuned and happy learning, and goodbye.